So, good evening, everyone. Hope all of you are doing good, and this lockdown is going well to everybody. So, today we will do the continuation of our last class. That is, in the last video, we have discussed a little bit about the sedative and hypnotics, and under the classification, we found the benzodiazepines and barbiturates. In the previous video we have discussed about the SAR and synthesis and classification of benzodiazepines. So today we are going to discuss about the remaining portion, that is the barbiturates. So if we can define the barbiturates, or the simple description, this is the most or the oldest class of drugs which are used as sedative or hypnotics, or we can, in simple word, we can say that which are used to relax the body and help people to get some sleep. So comparatively from the benzodiazepines, these barbiturates are used from before. So these are the older one. So if we go further, then the classification of barbiturates, so these are also then classified based upon the duration of action. So the long-acting barbiturates, the intermediate acting barbiturates, and the short-acting barbiturates. So under the long-acting barbiturates, we can find the barbital and phenobarbital. The intermediate acting barbiturates, we find amobarbital and tolbutal, and the short duration or short-acting barbiturates, that is phenobarbital. And here the long-acting barbiturates, the time ranges from 6 hours or more. The intermediates are 3 to 6 hours, and the short acting are less than 3 hours. So this was about the classification of barbiturates. Now if we go to the SAR of barbiturates, so all the barbiturates, known barbiturates which are used, are derivatives of barbituric acids. So again, today in the previous video, as I have said, the only idea I have come up with to show you the structures for synthesis or SARs is pen and paper. So today I will do the same. So if you can see, this is the structure of barbituric acid. This is the structure of barbituric acid. So as all the derivatives all the known barbiturates are the derivatives of barbituric acid. So this is the current structure, and if we number it, so this is the position 1, 2, 3, 4, 5 and 6. So all the derivatives are generally, they are obtained from the substitution or in the position 5. So removal of these two hydrogen atoms with aryl or alkyl groups, or substitute aryl or alkyl groups, give the different types of barbiturates. So the rest we are going to do in the classification. So we are going to discuss in the SAR what type of substitution will give what type of activity. So first we can see that the total number of carbon atoms present in the two groups, in both the groups of the carbon 5 must not be must not be less than 4 or more than 10 to get the optimal therapeutic activity. The second point in the SAR or structural activity relationship is that the only one of the substituents at the position 5 should be closed chain. So both the groups in the position 5 can't be closed chains, so only one can be closed chain, or both can be open chain. So the branch chain isomers, the third point is the branch chain isomers exhibit greater activity and shorter duration of action. The greater the branching, the more potent is the drug. So if we increase the branching in the substitution, so basically इससे क्या होगा, आपका potency बढ़ जाएगा drug का. So and the fourth point, we can say that double bonds in the alkyl substituents produce compounds more readily vulnerable to tissue oxidation, hence they are short acting. And the stereoisomers of the have the more or less the same potency, so anyone can be used. Aromatic and alicyclic moiety exerts greater potency than the corresponding aliphatic moiety having the same number of carbon atoms. And the next point, we can say the short chains at position 5 or the carbon 5, that the one I have shown you here, So the short chain at position 5 resist oxidation and hence are long acting, and long chains are readily oxidized and hence they are शॉर्ट एक्टिंग. मतलब जितना लंबा चेन होगा आपका ड्यूरेशन ऑफ एक्शन उतना कम होगा. और दे विल द ड्रग्स विथ शॉर्टर chains come shorter chain in the position 5 come under the long acting or long duration of action, and with long chains as a substitution comes under the barbiturates with short duration of action. So inclusion of a halogen atom in the alkyl group in the fifth position. So in the fifth position in any one group, if you can attach the alkyl groups in the fifth position are having a halogen atom like chlorine or iodine, so it increases or enhances the activity. And the next point will be like inclusion of polar groups, that is like groups like OH, CO, COOH groups in the fifth alkyl moiety reduces the potency considerably. And if we can go further, like methylation of any one of the imide hydrogen. So here we are talking about either this hydrogen or this hydrogen. Okay, so methylation of any one of the imide hydrogen enhances the onsets and reduces the duration of action. So what does this mean? Like it means like transition of 5,5 disubstituted to 1,5,5 trisubstituted barbituric acids. So if we can do these types of substitution, like one substitution here and two substitution in this H atom, so it what does it results? It enhances the onset and reduces the duration of action. Now replacement of the sulfur for the carbonyl oxygenide carbon results in the thiobarbiturates, which exhibit rapid onset and short duration of action because these are readily detoxified. So the second position is this one. So if we can replace this oxygen atom with a sulfur group, so which will result in thiobarbiturates which exhibits rapid onset of action. So inclusion of the next point is the inclusion of more sulfur atoms, example like 2,4-dithio or 2,4,6-trithio decreases the activity, and replacement of the hydrogen atom at the carbon not in the carbon, in the nitrogen atom at 1 and 3 replacement of these two hydrogen atom at position 1 and 3 with alkyl group increases the vulnerability of the molecule to for tissue oxidation. So this was about the SAR. So what the conclusion we can draw from the SAR is that both the nitrogen atoms in the ring are important for the activity, and most of the derivatives of barbituric acid which are used as sedative in hypnotics are because of the substitution of this or the replacement of these two hydrogen atoms with alicyclic or aromatic or alkyl chain, so disubstitution derivatives. So these are the basic SAR for barbiturates. Now we have also discussed some of the synthesis of different types of barbiturates. So in the class notes I have given synthesis of two types of barbiturates. First one is phenobarbital. So again we have I have used the pen and paper to show you the structures which are used for the structural representation of the synthetic process of phenobarbital. So the first one, phenobarbital, the first one you can see here, it's urea. Urea when treated with diethyl ester of ethyl 1-butyl ethyl 1-methyl-butyl malonate. So urea treated with this compound under condensation will directly give phenobarbital. So here you can see this. There are this one hydrogen of this amine and this amine along with as C2H5O. So we can say there is a removal two molecule of C2H5OH, or ethanol is get removed. So one C2H5O from this part, one C2H5O from this part, and two hydrogen from these two amine get removed and form a cyclic compound which will give phenobarbital. Okay, so this was the synthetic scheme for phenobarbital, and the second one is aminobarbital. So here we can see when the reaction occurs with treatment of diethyl ester of malonic acid and it's diethyl ester of malonic acid and 1-chloro-4-methyl-butane. So here there is a removal of HCl get removed, and this H and this Cl get removed to give what I was saying. Okay, so and HCl gets removed to give ethyl isophenyl ester of diethyl malonic acid. So this is ethyl isophenyl ester of diethyl malonic acid. So which upon treatment with urea, will give this upon treatment with urea will give ammobarbital. So here you can see again, like the previous synthesis, we can see that the hydrogen atom from both the amines of urea and C2H5O from the ester gets removed. So two ethanol molecules get removed to give the cyclic structure of ammobarbital. So this was all about barbiturates, and hope you have I was clear enough to make you understand the little bit what I could discuss today. So hope all of you are fine, and I wish all of you stay safe and stay home. Thank you.